I guess we can just get down to it. We were talking towards the end last time about minimum duplication circuits. I hope everyone's had a chance to check out their tests. I also posted, as promised, I posted my own answers to our test questions, so you can check those out if you are unsure about, how to do it right if I said you did it wrong. I'd be happy to get together with anybody and go over them too. Anyway, minimum duplication circuits. I'm going to write MDC. This is what we started talking about towards the end last time. The idea here is these are a circuit which uses all edges while repeating as few as possible. As few as possible. All right, that's what a minimum duplication circuit is. It uses all edges while repeating as few as possible. All right, in theory, the best possible would be repeating 0 edges. That is an Euler circuit. But for a typical graph, that's usually not possible to do it by repeating 0 edges. And so the next best thing is minimum duplication circuit, which repeats as few edges as possible. And towards the end last time, we talked about sort of how to decide which edges you want to repeat. So to decide which edges are best to repeat. Here's how to decide. For example, I will just draw, I think we talked about this particular example last time. This kind of simple grid here. What you should be looking for are the degrees of the vertices, and in particular you are looking for odd degrees, because the odd ones are the ones which make it so that you're going to have to repeat some. So I'm just going to write in all the degrees. This you really need to be very comfortable with just looking at the picture and right away saying what all the degrees are. So in this case I have many odds. That means an Euler circuit is not possible because there are a lot of odds. There are actually 8 odds in this one. And if you just make up a graph at random, you will expect there's going to be lots of odds. There's no real good reason why everything ought to be even. So usually you're going to see a lot of odds. All right? And to decide which edges are best to repeat, what you want to do is pair up the odd degree vertices. Pair up the odd degree verts which are connected by edges. What I mean by that is I see like these two up here, I want to make them go together because there's an edge connecting them. Whereas like those two, they don't really go together because there is no edge connecting them. And certainly like this one up here does not go with this one down here because there's no edge there. So I'm going to pair up the odd degree vertices which are connected by edges. I see I can make nicely a pair there, a pair there, a pair there, and a pair there. And these are the edges which we will duplicate in our circuit. These are the edges which we'll duplicate in the minimum duplication circuit. And in this particular example, that means it will require 4 edge duplications. And it's going to be those 4. All right. So here, in this example, we'll require 4 dupes. Right? 4 duplications, because that's what's necessary. And remember, the reason why we are like trying to join them up with extra edges is because these guys used to be 3, but once you put another edge in there, now this degree is 4. because now there is 1, 2, 3, 4 edges there. So these, which used to be 3, are actually now 4. And similarly here, and here, and here. And now, having put those in, now there are no odds left, which means I can do an Euler circuit. That is to say, there is a circuit on this one with no repetitions, although this one now includes doubled up edges 4 times. All right, and so now I'm going to draw, so let's draw the minimum duplication circuit. I'm going to just make that picture again. This is my graph, and I am going to now draw a circuit. This is going to be like an Euler circuit. I'm going to draw my intentionally slightly sloppy line going around the graph, maybe start going down like that, where I am going to duplicate some of the edges. So sort of in the back of your mind, you should remember, I'm going to go over this one, this one, this one, and that one twice. All right, but everything else only once. And I hope that you feel okay about drawing the circuits like we did last time. This is just like that, only I'm going to duplicate those 4 edges that are indicated. So let's just do it. Maybe I'll go down here. Okay, so I went down that once. I'm going to, at some point, revisit that edge and go across it again. But I'm not really going to worry about that, but at some point I'm going to do it. Maybe I'll just go back up here. All right, and I got that edge for a second time. All right. Remember, as you draw your path here, you can usually kind of do whatever you want. The only thing, what you should have in the back of your mind is all the edges which you did not hit yet, which are all of these over here, they should all be in one connected portion. They should not be split apart into 2 separate parts of the graph. And that is still true at this point. All the edges I didn't hit yet are still all together over here. All right, so I'm going to continue. Maybe I'll go down here, over there. Remember, you're not allowed to repeat any of the edges except for the ones that I said I was going to repeat. From there, come down. Here, actually, I have to hit these guys, because if I go to the right here, then these will be cut off forever. So I'm going to go like so, and then immediately back across this one. That was one of the ones I was supposed to repeat, and I just did. All right. Maybe I'll go up here, up here, up here, up here, over there. Here is another repetition of that edge. All right, I think I'm doing okay so far. Remember, what you should try to keep in mind is where are the ones I didn't hit yet? They're all up here. It's not disconnected, they're all together, which makes me feel good about it. All right, so I'll come over here, and here I'm gonna do this edge twice. And I made it back home. All right. So this is a minimum duplication circuit with 4 duplications. They are here, 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 and here. 4 dupes. All right. Everything else I hit, all the other edges I hit only once. But I had to run across those 4 twice. Anybody got thoughts about that? I have one for you all to try. It's a little simpler than that. So you all try. You should probably draw it big. It just makes everything easier to see. This one. So your job, find and draw a minimum duplication circuit. You should decide, first of all, which of the edges are you going to be duplicating? And then see if you can do it. Remember, the way to find which edges to duplicate is, as I discussed, I'll try and scroll it out so you can still see. This business here, pair up the odd vertices. That's how I knew that those 4 were going to be the ones that I duplicated. See if you can do the same thing for this other one. those two and copy that edge.
Okay. Oh, okay.
Yeah, and then the bottom one also. Now, if you also do the ones on the sides, then actually these fours will be eyes, which is bad. So you just do that one and that one.
Okay, got it.
I'll give you a couple more minutes and then we can talk about it. All right, you should draw it in.
Yeah.
Good here? All right, let's talk about this. People seem to be doing okay here. So this one here, we must look first at the degrees, all right? So they are 3, 3, 3, 3, and a 4 in the middle. And the odd ones, of course, are these 3s. And now we should, following my advice from before, we should group them together in pairs and duplicate the edges which connect each pairs. Now, and in this example, there are 2 ways to do that, and different people did it different ways. I'm going to group together the 2 on top and also the 2 on the bottom. So if I add an extra edge across the top, that makes this a 4 and a 4. And the one across the bottom makes this a 4 and a 4. And I'm good with that. Like now they're all even, which I like, all right? You should not also, as I was walking around, some people try to also duplicate the ones down the sides. You shouldn't also do that though. If I also duplicated this, then these 4s become 5s, which I don't like. I want them all to be even. And so you can either duplicate the 2 horizontal ones across the top and the bottom, or you could have duplicated the ones across on the 2 sides. And either one is fine. I just decided to do the top and the bottom. So this is going to require 2 duplications. And in my case, the ones I'm going to duplicate are the one on the top and the one on the bottom. And so I'm going to try and draw my picture now. Some people didn't want to redraw the picture, which is fine. I find it easier to start afresh. So, and now I'm going to draw my circuit, and you can, as usual, start wherever you like. I'll start over here. And I am going to I'm going to repeat the edge on the top and the bottom. As usual, you can just kind of draw this in however you like. Just make sure that you actually, so here I go repeating the bottom edge. And now I'll do this one. Up here, across there, and then back across. There you go. I repeated the bottom edge and also the top edge. Yours probably looks different from mine, but there are so many ways that you could do it. Anybody got thoughts about that? I hope that it came together for you. All right, there were 2 edge duplications, and they are here and here, right? 2 edges repeated. Okay, excellent. Actually, this is basically the procedure for doing this minimum duplication thing. This is actually a slightly easier one. There are some, it's not much harder, but there's one just kind of little variation on the strategy which sometimes becomes necessary. A bit more complicated, not really, but you just have to know how to handle. Sometimes the odd ones do not naturally occur in pairs. Here's what I mean by that. Here's an example. This looks like kind of a sumo wrestling guy, some kind of big guy. swole, as they say. Is that what they say? Yeah. I myself have never been terribly swole, if I understand the meaning of the word. Low key. I also know people say low key sometimes, although it's hard for me to understand exactly when is appropriate to say. Or more accurately, when is it not appropriate to say low key? It seems to me like you can just say that low key whenever you want. And it just kind of, I don't know when is it not okay to say. I'm not sure. Like, I low key want a divorce. Is that okay? I feel like people would still say that though, wouldn't you? If you were like talking to your girlfriend, like, oh man, I low key feel like I want a divorce. Isn't that, you would say that, right? Yeah, I don't know. Anyway, what is more complicated about this one? All right, this one is a bit more complicated. It's not obvious when you first look at it, but you should, as usual, just look for the degrees. So these are 2s on the corners. There are some 4s where you see 4-way intersections. There's a 3. Okay, that's a 3, and that's a 3. And actually, those are the only odds in this example. And what's more complicated about this one is the 2 odds do not already have an edge between them, all right? And so you may think, don't do this because this is wrong. You may think, can I just like create a new edge connecting that one all the way over to that one? And this is not allowed. It's because the whole idea of the minimum duplication circuit is you have to repeat existing edges. You're not allowed to just create a new edge which wasn't in the graph at all. So sometimes what's more complicated about this is sometimes the odds can't be paired up with edges between them, right? As is the case in this example, there are 2 odds, but they are not connected by an edge. And so you need to duplicate more than one edge in this case. So how to handle this situation is you find a path connecting them. Those 2 odds, they do not have an edge connecting them. So instead you have to find a path connecting them and duplicate all edges along the path. So in this case, this 3 and this 3, they do not have a single edge, but of course there is a path going across the top here consisting of 3 separate edges. There's this, then this, then this, and we duplicate each one of those like so. All right, find a path connecting them and duplicate all of the edges along that path. And look at what is the effect on the degrees. When I make that first edge on the left here, this 3 is now a 4 because I added an extra edge. What about the 4 here? Well, I added this extra edge, so that makes it a 5, but I also added another edge, so that actually makes it a 6, and it's still even. So this is still going to work. This 4 has now become a 6. This 3 has now become a 4. And so it is the case that they're all even, which is what I wanted, low key. Right? They are now all even, and so we should be able to do the same business with our minimum duplication circuit. So this is the only thing that can happen with this little bit more complicated situation. Sometimes the odds cannot be paired up by individual edges, which means you have to find a path and just duplicate all of the edges along that path. All right? So this one, maybe I'll draw the, well, I will just say this will require 3 duplications, 3 edges, right? It's that one path which consists of those 3 individual edges. 3 duplications. And can I try and draw it? So I'm going to draw this picture again. All right, and maybe I'll start in the corner. Since I'm drawing a circuit, it really doesn't matter where you start. Just remember I said I'm going to do the edges which I'm going to repeat are here, here, and here, right? I'm going to have to do those ones twice. But otherwise, I'm just going to go about my business go across here. There's no real funny business here. I'm just kind of doing whatever to cover all of the edges without repeating any, except for those ones that I am going to repeat. So here's my first repetition. I went back across that one, and then back across this one, and then back across that one, and all the way back. So there it is. This is a minimum duplication circuit with 3 repeated edges, or 3 duplications. All right. I got a few more for you all to try. Now these ones, sometimes, if I want to like make it a little easier on you, instead of asking you to do all of this, I might just ask you to decide which of the edges would have to be duplicated, and then you don't have to draw the results. So that would be just sort of this much, but not drawing it in. So if I wanted to make it a little easier on you on the homework or on our tests, I might just say, how many duplications would you need and which edges would you duplicate? So I got a few for you to try like that. Each time, just decide which edges you would duplicate, but don't actually draw the minimum duplication circuit. Now some of these you can pair them up just by individual edges, but some of them you will need to use paths. And I will leave it to you to see which is which. In all cases, you should start by writing the degrees and then looking for the odds and so on. See what you think. Feel free to talk to your friends about it.
Yeah.
So what, I think, yeah, okay.
Okay.
What you're duplicating are edges, not vertices.
Okay. Oh, okay. Okay.
So I would say, I would say duplicate this. It's really on the half edge there.
Okay. Got it. Thank you.
Okay. Drawing them in just for fun. I said you didn't have to draw them in, but
Oh,
that's okay.
it's too late now.
It's too late, yeah. You're committed. How's it going?
Good.
Mm-hmm. I think you can do better on this one.
Really?
You have 3 duplications, but it's possible to do only 2.
Okay.
And this one.
Oh, these two are odd too. Oh, so like that.
All right, can we talk about these? I see this is kind of a lot here, but I see people doing okay. This I think the easiest one is actually this. This is the most kind of straightforward one because there are just 2 odds. The degrees here are 2. That's a 3, 2, and then a 2, 3, 2. I have these 2 as odds, and so I just duplicate that single edge. That makes these 4s. So this one requires 1 duplication, all right? And it should be that one down the middle, actually. If you just duplicated one of the other edges, it wouldn't work. Just that one down the middle. That's the most straightforward one, in my opinion. Let's try the one on the left, the square of squares there. These have odds here. And what makes this one slightly interesting is that those odds cannot be just directly paired up. Like these 2, for example, are not connected by an edge. And so you have to do, as I said, find a path connecting this and duplicate all of the edges along that path. And there are actually many ways to do that, but as I was going around, I saw people said, all right, to get from here to here, maybe I'll duplicate all the edges along that path. So that would look like this one and then that one. And then the other 2, I would similarly duplicate along the path going through the middle for them. And that would look like, say, that one and that one. All right. So this is one way to do it. That would be 4 duplications. Another way that you could have done that one, I'll move this one out of the way for now. Another way you could have done that one would be to connect, along a path, but along the outside. Like those 2 could be connected like that, and then the other 2 like that. This is the idea. So then that would look like here, 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 and here. But in any case, you need 4 duplications. There are many ways, and you could do some kind of mixture of those 2 strategies also. But you definitely need to do 4 duplications in that example. I saw some people say, can't I do it just going like 1 duplication across and then 1 across like that? This is not really correct. I mean, that's not 1 edge across. It's actually 2 edges because there's 1 in the middle. There's a vertex in the middle. So that, if you said I just did 1 here and 1 here for a total of 2, that's not right. It's actually a total of 4 because those are not 1 and 1. Those are larger. Okay, what about this sort of triangular type one down here? The degrees here are, that's a 3, a 3, a 3, a 3, and a 2. So I have 4 odds. Can we go pair by pair in this case, or do we have to make long paths? Actually, in this case, you can pair them up individually, and there are several ways to do that, but one would be something like that, right? And so you can do this one using 2 duplications. 2 dupes, right? Those 2. And there's, you could have also done the one on the right and then the sort of straight one. You could also do this and this as your 2 duplications. All right. And finally, this one, this is the weirdest one here. This one, when I look at the degrees, it has some 1s. 1, 1, 1, 2, 2, 3, right? And so I need to join up in pairs those 4 odds, and these really are very inconvenient to join up in this graph. You can join together the first 2 just right here, and that's fine. But then the other two, of course, you cannot create a new edge across the bottom. You must duplicate all of the edges along this path. And so in this case, this is kind of the worst possible case. Here it requires 5 duplications. I say this is the worst possible because actually in this example, you must duplicate every single edge. That's as bad as it could possibly be, but it is the fact here. It's not possible to do this without duplicating everything. So here you must repeat every edge, which is kind of the worst case scenario. Every edge, right? It does happen sometimes. All right, any thoughts about those ones? I hope those seem okay. You'll have some more practice with them on the homeworks. It's all about the degrees and the odds. All right? Great. We got 10 more minutes. That's enough time to talk about minimum duplication paths. Everything we've been talking about today have been about circuits. What about paths? It's actually a very simple variation. Minimum duplication paths. Paths. Come on now. Remember the difference between an Euler circuit and an Euler path. For an Euler circuit, you need all even. An Euler circuit needs all even. Euler path needs all even except 2 odds, right? And those two are the start and the finish. Starting and the ending vertex will be the odds. All right? So, how do we find a minimum duplication path? I'll call this MDP. Well, it's the same procedure, only instead of making all of the odds into evens, you're allowed to leave 2 as odd and make the rest even. So, to find a minimum duplication path, we do the same thing. We do the same as for a minimum duplication circuit, but we leave 2 odds and make the rest even. All right. Leave 2 as odd, make the rest even. So, for example, in the, this one that we just talked about, so how should I do a minimum duplication path? Well, again, you start by looking at all the degrees, and really all you care about is the odd degrees. There are 4 of them here. And the idea is we must duplicate some edges to turn them even, but you don't have to turn all of them even, you can leave 2 odds. So leave 2 odds and make the rest even by duplicating edges. And really it's up to you to decide which ones you want to leave as odds. So maybe I'll leave the top and the left as odd, and then I will repair the others by doing that. All right, so now this is a 4 and that's a 4. So I decided to leave the one on the left and the one on the top as odds, but I duplicated those other 2 there. All right, so this requires 2 duplications for a minimum duplication path. And if I were to draw it in, just for fun, remember, since I left those 2 on the left and the top as the odds, that means I have to start at one of the odds, and I'm going to end at the other one. So maybe I'll start at the top. I will just remind us, you have to start and end at the odds, right? And I am going to repeat here and here. Those are the two edges that I'm going to do twice as I drive around the graph. So here we go. I'll go around here. There's my first repetition. Here I'll do my second repetition. Sometimes it works out nicely to just immediately go back across the ones that you know you want to repeat. You won't forget to hit them again. There you go. This is my minimum duplication path. So it has a different starting and ending point. That's the difference between, of course, a path and a circuit. So this was the start. This was the end. All right. This is a minimum duplication path. I duplicated two edges. All right. We got 5 minutes. Let's just look at one more big example. This is kind of a big grid type diagram. A little 4x3 kind of grid with a few bonus diagonals in this arrangement. All right. So in this arrangement, I don't want to draw the minimum duplication path, but let's just decide which edges will we duplicate in a minimum duplication path, and also where will the start and end be. All right, if I'm talking about a path, it does matter where you start and finish, so I might ask, if I wanted to make it easier on you, I might not ask you to draw it in, but I might still ask which of the edges are you going to duplicate it. All right, and the way to answer this question, again, is based entirely on the degrees. So we should, at each vertex, say what the degree is. The ones on the outer corners are all 2s. A three-way intersection is a 3, so that's a 3. This right here is a 4 because there are 4 roads meeting right there. That's a 4, that's a 4, that's a 4, a 4. This over here is a 3. All of these three-way bits are 3s. Maybe I'll draw in all the 3s. That's a 3, a 3, 3, 3, 3, and 3. There are a lot of 3s around the edges. Maybe I'll circle those just because they are the ones that I care about. The evens don't really matter for this type of problem. Here's another 4. This intersection is now a 5-way, so there's a 5, which is odd, so I care about 5s. This is another 5. This is another 5. So those are all the odds. I have circled all of the odds. All right, there are many of them. And how are we going to decide which edges to duplicate? As before, we're going to try to pair the odds up one by one and leave 2 of them unpaired, right? 2 of them can stay odds. The rest have to become evens. I am looking at these guys here. You should probably decide which one am I just going to leave as an odd, and then I'm going to try and connect all the other ones up. Does anybody see a good candidate for one to leave as an odd? There's actually one in this picture that I want to leave as an odd because it's not convenient to connect it up with any of the other ones. Anybody see what I'm looking at? Yeah?
Is it the 3 at the top?
Yeah, the one at the very top, I would like to leave this one as an odd because there's no edge from this one to another odd. So if I wanted to say connect this up with here, I'd have to actually go 2 edges, which I would rather not do because I want to do this using as few as possible. So I'm going to try and pair up all the other ones, leaving this one like it is. So maybe, and as usual, there are many ways you could do this, but maybe something like those 2 go together, these 2 go together, these 2, those 2. I should have 2 odds left over. What did I do wrong? Something ain't right in this picture. Yeah?
What about the bottom corner?
Yes, thank you. This is a 3, not a 2. Thank you. Yeah, I got one of my degrees wrong. That's a 3, so that's an odd. All right, so now there are 2 odds left, right? Here and here are the 2 odds that are left over. So those are going to be my starting and ending points, and all of the other ones are going to be duplicated. So, I mean, it doesn't matter, but let's just say that's the start and that's the end. And we, other than that, we have 1, 2, 3, 4, 5 duplications. 5 duplicated edges. Sorry, I counted that one wrong. All right, there you go. So which edges will we duplicate? It's those 5. And where will the start and end be? It's those other 2 odds left over. Great. That'll do, I think. Hope you all have a good week.